ground classification is our latest module added in mdInfinity Cloud and mdInfinity Desktop, and you can find it available since mdInfinity Cloud version 2021.5 and mdInfinity Desktop since version 2021.4. This module has been optimized to work with any LiDAR UAV solution, and the main thing of ground classification is that it allows the user to isolate the ground from any other feature in the point cloud. Why to use ground classification in mdInfinity? Well, the first thing is that it is fully optimized to work with any microdrone solution and to work in the microdrones and mdInfinity environment. It is fully integrated workflow in mdInfinity Cloud and Desktop, where you can process end-to-end LiDAR. The classified point cloud generated by ground classification can be used later on to generate a digital terrain model and later on contour lines. Ground classification is an automatic process where the user introduces the point cloud and extracts the point cloud with the classified ground. Now, how is ground classification workflow in mdInfinity? Our recommendation is to first, in mdInfinity, use trajectory processing, later move to strip adjustment, go to precision enhancement, and finally use ground classification. After this, you will extract the classified point cloud. Now, what is recommended and what is obligatory to use ground classification? Ground classification can be used directly from any LAS files without using strip adjustment or precision enhancement. But we strongly recommend to improve your point cloud before using strip adjustment and precision enhancement. The first part that will be a strip adjustment, it avoids the duplication of the ground surface. As you can see in the graphic, you can see the strip A and strip B, and what is when it's adjusted, you can see the profile. Precision enhancement, what it does, it reduces the ground offsets and out layers. This means that when ground classification is trying to identify what part is the ground, it will improve the classification.
At this point, Jaume, let's log into mdInfinity and take a closer look at processing the data and see how we can isolate the bare earth points from other objects such as vegetation in the point cloud.
Thank you, Robert. Now we are going to see ground classification workflow on mdInfinity Desktop. Just to mention, all these modules are available also on mdInfinity Cloud. The first thing to see is that in this version, 2021.4.2, mdInfinity ground classification is available. If you have an older version, please upgrade to the latest one. Now, in this version, we can see all the modules that we mentioned during the presentation. The first one is georeferencing. The next one is strip adjustment, precision enhancement, and ground classification. The essential workflow to make ground classification work is georeferencing and ground classification. But we strongly advise as a best practice before to do ground classification, start with a strip adjustment, precision enhancement, and later move to ground classification. Now, at this point, we are going to see how ground classification module works. I have already used a strip adjustment and precision enhancement on my point cloud, and I will just jump on the classification. We select ground classification, and the first part, we need to select our payload. Ground classification module has been optimized for each of the payloads introduced. If you have an MD LiDAR 1000 HR, by default, the settings that will appear will be optimized for your payload. In the first screen, it asks for the input files. Here, we need to introduce the LAS files generated by precision enhancement. Then we come and we select our generated LAS files. The next step, we will click next, and we have the output section of ground classification. The first thing that we will do is to create a new folder to save the ground classification. The next thing, we have two settings. One is merge all inputs file before classification and export one LAS by merging all input files. We strongly advise always to use merge all input files before classification. The next thing is the classification parameters. Ground classification has been optimized with default terrain profiles. If you choose one of these terrain profiles, all the advanced settings will be optimized for that type of profile. In my case, I'm working in a hilly urban environment. This means I will select this terrain type. In maximum building size, I know that the only building in the area is around 15 meters. I will select 15 meters building size, and the slope I know that is around 45 degrees. You can also have a look to the advanced settings. Here we have different settings corresponding to every single parameter that can optimize the processing of ground classification. If you don't know how to use these parameters, you can use the default parameters for each terrain type. But if you know, modifying these parameters will improve the classification output. In this case, I will use the default parameters. We will press next, and we will process. After the processing is done, we can jump onto the viewer to visualize the classification and evaluate if the classification was good enough or we need to repeat it. In this case, we can see the point cloud generated by elevation. We will, in the viewer, go to a scene, select the files. We will say attribute, we will select classification, and here we can see the classified point cloud. As you can see, on gray color is the 3 buildings and the trees. And in orange color, we can identify the ground. This is a good indicative that the ground classification output was good. To double check that everything in the ground is part of the ground, we will go to filters and we will check and classify point cloud. And in this case, we can see that only the bare ground was used during the classification. This means that the classification, it was good, and we can jump to use this classification to generate the DSM, DTM, or any other mapping output needed.